Now before we start the numericals of the lesson number 4, that is effects of electric current, remember all the formulas. First of all, P is what? P is what? Power. The unit of power is what? Watt. It is what? Watt. The unit of power is what? Watt. I is what? Current. And the unit of current is what? Ampere. Now potential difference, Q is what? Charge. The unit of charge is what? Coulomb. Now potential difference, the unit of potential difference is what? Volt. That is V. And R is what? Resistance. And the unit of resistance is what? Ohms. Now the formulas which we have in this lesson is what? First one is what? P is equal to V into I. So P is equal to V into I, that is power is equal to volt into, that is potential difference, into current. Similarly, according to Ohm's law, V is equal to what? I into R. Now if you apply, so therefore I is equal to what? Bring this R on this side, you'll get V upon R. Now apply this formula over here, that is V into I. Instead of I, you put V upon R. You'll get what? P is equal to V into V upon R. That's equal to V square upon R. So this is another formula which has been used in this lesson. Now next one, heat energy, that is H is equal to, so H is what? Heat energy. And unit of heat energy is what? Joules. Next is what? Heat energy, that is H is equal to P into T. T is what? Time, that is in seconds. And one more formula of H is what? That's equal to V into I into T. V into I into T, that is heat energy. Another formula of heat energy is what? I square into R into T. I'll repeat once more. Formulas used in this lesson is what? P is equal to V into I, that is power is equal to potential difference into current. Then according to Ohm's law, V is equal to what? I into R. R is what? Resistance over here. So when you I is equal to what? So if I shift this R on this side, I is equal to what? V upon R. So if I put in the place of I V upon R, I get another formula of power. Power is equal to what? V square upon R. Now heat energy, that is H. H is equal to what? P into T, that is power into time. H is equal to what? V into I into T, and H is also equal to I square into R into T. So according to the information given, you have to use the formula. Now we will start with the numericals of this lesson. Now solve the following example. Question number 12, first one A. Heat energy is being produced in a resistance in a circuit at the rate of 100 watt. So P is given, that is equal to 100 watt. The current of 3 amperes. So current, that is I is given 3 ampere, is flowing in the circuit. What must be the value of resistance? So R we have to find out. Now first, in order to find out R, first we have to find out V, that is potential difference. We know that P is equal to what? V into I. That is V is equal to what? P upon I. So V is equal to P upon I. Put the value, that's equal to P is how much? 100. And I is how much? 3. So 100 upon 3 volt. Now we will find out resistance. I is equal to what? V upon R. Since we have to find out resistance, take this R on this side and bring I on this side. So R is equal to what? V upon I. That's equal to what? V is equal to how much? 100 upon 3. And I is equal to how much? 3 ampere. Now this 3 is what? 3 upon 1. When you take the denominator on the top, you will get what? R is equal to 100 upon 3, and when you take this denominator on the top, it will become 1 upon 3. That's equal to 100 upon 9. When you divide this, you get 11.1 ohms. So R is equal to approximately equal to how much? 11 ohms. Now second one, B part. 2 tungsten bulbs of wattage 100 watts and 60 watt power is used. So let bulb 1 be equal to, let us take that as P1. Bulb 1, let us take that as P1. That's equal to how much? 100 watt. And bulb 2, let us take that as P2. That's equal to 60 watt. Now in both this, same potential difference is applied, that is 220. So V is equal to 220 volt. Now if they are connected in parallel, how much current will flow in the main conductor? So how much current it will flow in the main conductor? So we have to find out this. Now I is equal to what? I1 plus I2. So we'll have to find out first I1 and I2, and then you have to add it. So we know that P is equal to V into I. Therefore I is equal to what? P, bring this V below, we'll get V upon P upon V. That is I1. This is a common formula. So I is equal to P upon V. Therefore I1 is equal to P1 upon V. Similarly, I2 is equal to P2 upon V. So for bulb 1, we have to find out differently the current, and bulb 2 we have to find out differently the current, and then we will find out the total current, that is I1 plus I2. So I1 is equal to how much? P1 is equal to how much? 100 upon 220. V is equal to how much? V is common to both of them. So 220. And similarly, I2 is equal to how much? That is P2. P2 is how much? 60 upon 220. 220 is common to both of them. I is equal to how much? I1 plus I2. That's equal to I1 we have got 100 upon 220 plus 60 upon 220. Denominator is common to both of them. So 100 plus 60 upon 220. When you add this, you get 160 upon 220. 0 and 0 will get cancelled. 8 and 11. So I is equal to what? 8 upon 11. When you divide this, you will get what? 0.72. It's a recurring number. 0.7272. This way it will come. So I is equal to how much? 0.72 ampere. So the total current which passes through the main conductor is how much? 0.72 ampere. Now 12C, who will spend more electrical energy? 500 watt TV set in 30 minutes or 600 watt heater in 20 minutes? Now they have given TV set. Power is equal to how much? 500 watt, and for how many minutes? 30 minutes. So T is equal to how much? 30 minutes. Convert this into second. That is 30 into 60. That's equal to 1800 seconds. Now next one, heater. Power used by heater is equal to how much? 600 watt. And time they have given how much? 20 minutes. That is in minutes it is. So convert it into second. That is 20 into 60. That's equal to 1200 seconds. Now we know that P is equal to heat energy we have to find out. Which TV set or heater which will consume more heat energy. So heat energy E is equal to P into T, that is power into time. So in case of TV set, we will get how much? E1, let us take that as E1. E1 is equal to how much? P is how much? 500, and T we have got how much? 1800, that's equal to 900,000 joules. So when you convert it into, take it in powers, 1, 2, 3, 4, 5. So into 10 to the power of 5 joule. Now we will find of heater. Same way, let us take the energy as E2 of heater. So E2 is equal to P into T, that's equal to 600 into, say time is how much? 1200 seconds, that's equal to joules, that is 7.2. After point you count 1, 2, 3, 4, 5. So into 10 to the power of 5 joule. So when you compare both of them, this is 9 into 10 to the power of 5 joules, and this is 7.2 into 10 to the power of 5 joules. Both are 10 to the power of 5 joules. So 9 is greater than 7.2. So who will spend more electrical energy? TV set. So TV set spends more electrical energy. Now sum number 12D, an electric iron of 1100 watt. So P is equal to how much? 1100 watt. Time is equal to 1, is operated for 2 hours daily. So T is equal to how much? 2 hours. So in energy consumed in 1 day. So how much hour does in 1 day? It works for 2 hours. So this you have to convert first into kilowatt. So 1100 upon 1000. So first convert watt into kilowatt. So this 2 zeros will get cancelled. Since it is 1 zero is there below, so that will become 1.1 kilowatt. So that's energy consumed in 1 day is equal to how much? 1.1 in 1 day is equal to P into T. So that's equal to 1.1 into T is how much? 2 hours, that is 2.2 joules. Now energy consumed for month of April. Energy consumed in month of April. In April, how many days are there? 30 days. So in 1 day, if 2.2 joules is used, then in 30 days, how much joules is used? 2.2 into 30, that's equal to 66. This is kilowatt hour. So in 30 days, how much it is used? 66 kilowatt hour. So that is equal to 66 units. I'll repeat once more. In 1 day, how much energy is consumed? 1.1 into 2 hours, that is 2.2 kilowatt hour. Kilowatt hour. Now energy consumed in the month of April. In the month of April, how many days are there? 30 days. So in 1 day, if it is 2.2 kilowatt hour, then for 30 days it will be how much? 2.2 into 30, that's equal to 66. You'll get how much? 66.0 kilowatt hour. Since after 0.0 is there, so you can remove that. So 66 kilowatt hour, that is equal to 66 unit. Now in the bracket they have given the electric company charges ₹5 per unit of energy. So one unit of energy charge of 1 unit of energy. Charge of 1 unit of energy is equal to how much? Rupees 5. Now how many units they had used? 66 units. So charge of 66 units of energy is equal to how much? That's equal to 66 into 5. So that is equal to how much? Rupees 330 rupees. What will be the electrical consumption expenses for the month of April? So the electrical consumption expenses in the month of April is how much? 330 rupees.